Dear colleagues, ladies and gentlemen, so it's my big pleasure to be here and present development what we carried out in the recent time, in the last 2 years. And this was the AI-driven image analysis for NDT performance. So if you talk about NDT and the digitization, what we can see is that the non-destructive testing is a major tool in the quality control and inspection in factory, and it's very important for the critical infrastructures to justify flow conditions of components and structure, to determine the inspected components of the structure as acceptability for safe operation, and to have a safe and general public and environment. So why we need a digitization solution in serving NDT? Because we have to increase the inspection safety and reliability, we have to reduce the time, and we have lack of human operators, and we have lack of the resources, and also sometimes we are working in risky environment. So like we have radiation around, maybe sometimes, so we have to deal with the safe the human operators' health as well. So what kind of problem we face to? The current radiology flow detection test is based on mainly manual evaluation. It requires human resource that is usually we are taking, and the result is needed to be digitally recorded and to keep for later. And we have to a separate step analysis which can introduce error into the process. So therefore, a purpose increasing both efficiency and reliability is needed. Kind of automated process can help of it. So the purpose of the goal was to develop a complex image analysis system, evaluate the application and the evaluation software that can evaluate the X-ray images based on standard requirements and of mainly on metals and the alloys, and especially we focus on the welds. And the solution is mainly based on the application of AI tools. So the application architecture is based on that if we have a laboratory information system, and from the system we can have information that you can see here. This is the oh yeah, in this case I can see the where the mouse is. So I'm coming the other side. Maybe if I can find the mouse. Can you see the mouse? No, I don't see. Okay. Yeah. Appeared though. It appeared for a while, but I can't see it from this point. So never mind. So we have a laboratory information system here. From this system, we have to transfer we have to connect the application clients, and the clients can have the evaluate the X-ray images. So we have to provide a database, providing database, user administration. We have to deal with the project management and permission issues, and we have to store the result. And after that, in the clients has to run on the local computer the application software, and they need a back and forth communication with the laboratory image, laboratory integrated management system, information management system, and the AI image analysis runs on the clients, and manual imperfection correction can be routed on the client application, and this is mainly based on should be based on the standard tools. So what kind of focus point we have during this evaluation? You can see this the limb connection is one of the most important issues we have to solve. After that, we need the standard implementation is also very important. From the information system, we have to upload the data to the, or download the data to the editor module, where we can have a manual correction, drawing functions, and after that we need the image analysis, and after that we have the automatic evaluation of the discrepancies found on the image, and this is kind of step we should have. So you can see the application workflow now that you can see that we have a input image that goes to the AI tool, and also goes to the data storage, and from the EI to the detected imperfection list is listed, and the binary imperfection is carried out, and classification can be carried out, and all the information goes back to the F1 side for the data storage for later learning, and goes to the result window where we can have a supervising and user manual correction that can improve the applicability and the efficiency of the evaluation. And after that, the imperfection flows list can be listed, and we can have a final result. And also the result window for the goes to the evaluation of the standard, and we can upload the result back to the laboratory information management system. So just one mention about the user manual correction. That means that we have a zoom in out using drawing and some kind of tool that can be used for the user manual modification. So the evaluation mainly based on standard. That's in pressure vessel industry and in this kind of and if we have welds, we usually based the evaluation and usually based on standards. So especially in the NDT evaluation, this section is a highly standard based work. So we have special standard for welds and aluminum alloys, steel, nickel, titanium alloys, and also how to analyze the tubes, for instance. So what we use is nowadays, we can say it's a traditional unit tool, what is almost 10 years old, maybe a little bit more than 10 years old, what introduced for medical application for cancer diagnostic, but nowadays it can be very widely used in image recognition. So we can use it for binary masking and then classification later. So this is how it looks like. So first we have a binary classification. The imperfection can be found. So we can identify this imperfection or not imperfection, and the unit algorithm can do it. And the user encoder model, what was presented in this morning, is a RegNet algorithm. And the optimization is, if you would like to know, this direct dice loss algorithm is based on that. And after that, if we have a classification, the binary classification, after that it goes to the classification where the ResNet application is a deep learning module, gives us a kind of result. And this is mainly based on the cross-entropy loss method and the Adams algorithm. So you can see here the generating learning data based on, this is the basis of artificial intelligence tool. So the label was carried out by specialists. So we have a kind of image you can see on the bottom of the picture, and above that you can see the colored imperfections what was carried out during the evaluation, and this is the label. So the label based on the list of the ISO standard you can see on the left. This is left-hand side, for us the right-hand side. So after that, we have a X-ray image imperfection list, what the software can give us. So this start from the LIMS server, the project test the specimen welds, and can download it, and loading the X-ray film. The metadata is displayed. After that, the user can start the EI analysis. And after that, the AI analyzes the evaluation of the detection is shown in the list, and we can accept it, and we can modify it, and then so on. So later. So nowadays it seems to it works. This pictures or this slide shows that we don't have to accept everything what the AI detect for us. We have a supervising and the modular collection editing module, because if you have improving data methodology in AI, you need always a continuous learning module that in this editing module helps you for the correction, where the detection based on AI can be improved for and can be teach the AI back. So finally, the evaluation can be carried out, and now we have the evaluation according to the standard. So we have a evaluation result. So you can see a very short movie about that how it looks like and how the user will carry out the application. So it is what I mentioned. This is we have the limb system. We have a project. The welding was loaded. We can select the picture or image. NDT X-ray image was selected. First, the AI-based imperfection evaluation can be carried out. The AI learned labeled specialized list can be shown here. So you can see that we have some imperfection, and this is what the AI-based imperfection list on the standard can be seen here. You can see the sizes as well and labeled of based on the classification. So this is detected. So as I mentioned, the size and the length and the width can be found. And also we can select one imperfection, for instance, as it shows this small video. And also it can be edited or we can have evaluation according to the standard. Just it will show if it goes the manual correction module. So if we select imperfection, and we are not satisfied with the AI evaluation result, that can help us to further improving of the results. The user can select what kind of imperfection he can see on the picture. So he will select the certain type of imperfection based on the standard classification, and the user colors the imperfections. And after that, it goes back to the database and improve the AI tool. So you can see that how it is carried out. So, and finally, you can see the automatic evaluation of the new imperfections as well. And also it is included. And after that, we have this list, and we can also select it. And case by case, defect by defect, we can check what we can see on the X-ray. And so it's a kind of continuous system learning based. And the correction is also possible. And it's not only possible, but the supervising is not just needed because of the AI and we have to improve it, but it's also very important because it's required by the standard. So without human supervising, no any software tools is allowed for NDT image evaluation. Just as a picture that shows this if the same. So as I mentioned, this is a continuous system learning is improved. So the pre-evaluated images are based on the AI given a new value based on any correction made by the user. So it will be uploaded, and these from the new learning data. These are from the new learning data in the system. So the corrected images are uploaded in the database back to the limb system, and then the system continuously learn thanks to the growing amount of the data. Actually, a lot of data would be needed. Nowadays, we have more than 1,000 image behind that. It should be maybe 10,000 actually, but it will be later. So it is continuously improved. So nowadays, I would like to summarize that the goal was to create a unique specialized knowledge base, and the current focus of on the data is corrected during the procedure for the evaluation of the image X-ray images. Actually, we can have a fast, efficient, automated image analysis and evaluation. And very important to understand the range of the standard can be extended as much as possible as we want. So if you will have a special standard needed requirements, it can be easily used or implemented. And always the expert approve the results, so they don't have to worry about the AI do something what is not really acceptable. And so it's very important to emphasize that the final evaluation is a human-based evaluation. The AI tool helps for and increase the efficiency of the NDT image evaluation. So thank you for your kind attention.